So now we're getting into solving equations with radicals. And so there's a process of solving these equations with radicals. So let's first walk through the steps of doing that, and then we'll go through solving multiple equations. Okay, so steps for solving radical equations. So first thing that you want to do, if you have a radical inside your equation, you want to isolate. There might be more than one radical, but you want to isolate one of the radicals on one side of the equation and get everything else to the other side of the equation. So isolate the radical to one side of the equation. And again, if there's more than one radical, then we're going to just isolate one. So once we've isolated that radical, we can clear that radical that we isolated by raising both sides of our equation by the index of that radical. So just kind of terminology and just to remember or recall, if you had the nth root of b, this number inside here, this is called the index. If we had the square root and the index is not shown, the index is 2. Okay, and if we had the cubed root, this would be, the index is 3. And we could go on forever. Okay, so we're going to raise both sides by that index to clear the radical. So raise both sides of the equation. What we do to one side of the equation, we got to do the other. Raise both sides of the equation. By the index of the isolated radical. Okay, so again, that's going to clear our radical. Then you're going to simplify both sides. We're going to repeat the same process 1 through 3 if there's remaining radicals in the equation. So repeat steps 1 through 3 if there are radicals that remained in the equation. So once we've done that, we've cleared all the radicals from our equation. The next thing that we want to do is we're going to solve for the equation. So look at what type of equation you have. Is it linear or quadratic? And decide how you're going to go about and solve it. I'll just give myself more room. Okay, so solve the equation. And then it really depends. If we raise both sides of our equation by an even power, then we might get what is called an extraneous solution, which means it's an answer that actually doesn't work in our original equation. And so we always need to check to make sure your answers our solutions to the original equation. If you raise both sides by an even power. Doesn't hurt if you do it anyways, if it was an odd power, but at an even power, we might get solutions that don't work. So both sides to an even power. Extraneous solutions could occur. Okay, so that's the process that we walk through every time we see an equation that has a radical in it. So let's look at an example. I pulled this from those in class notes. So when the variable of the equation occurs in the square root, cube root, or so on, the equation is called a radical equation. So for this first example, we have the square root of 5x minus 1. And then in the square root, that 5x minus 1 is what our radical is. And then equals 3. It's radicand, not radical. So first thing we want to do is isolate the radical. Well, notice that's already isolated, right? That square root is already by itself. So it's already done for us. There's nothing to do there. And then we're going to raise both sides of the equation by the power of the index. And so in our case, we're going to square both sides. So squaring the square root, that cancels out the radical, just leaving us with the radicand, which is what was underneath the radical. So in this case, 5x minus 1 equals, and then we squared the 3, so we get 9. So again, look at what type of equation you're left with. We don't have any more radicals in this equation. Once we square both sides, we don't have to repeat the process. I notice it's a linear equation, and so I need to isolate my variable. So let's add 1 to both sides. So adding 1 to both sides, we're left with 5x on the left-hand side, and then 9 plus 1 gives us 10. Divide both sides by 5. That's going to get us our x value, and then x is equal to 2. So we raise both sides by even power, so we need to check. And so we're going back into the original equation, and wherever I see an x in the original equation, I'm going to just first replace that with a parentheses. So we have the square root of 5. I see an x there, so let's put parentheses. And then minus 1 underneath that radical, and then equals 3. And so I'm going to go in here and I'm going to plug in 2 wherever I have a parentheses, but there's only 1 in that equation. And so we're going to check it. Order of operations, we want to simplify underneath the radicals first. And so we have, and we're just questioning, so I'm going to put a question mark here. So 5 times 2 underneath that radical is 10, and 10 minus 1 is 9. And so the square root of 9 equals 3. And that is a true statement. So I know that my solution is 2. So let's pull another example. And this one again is from the notes. Okay, so for our next example, we want to solve for y, and we have the square, y is equal to the square root of 2y plus 9. And then get out of underneath the square root, and then we have a minus 3. So first thing we want to do again is isolate our radical. In this case, our radical is not isolated. And I noticed because we have that minus 3 over here. And so we want to get rid of this minus 3 on this one side of the equation, I notice I can add 3 to both sides of the equation. And so doing that, we get y plus 3 is equal to the square root of 2y plus 9. Okay, so the radical is isolated. So we want to square both sides of our equation. So we're raising both sides of the equation by the second power. So we're squaring both sides. So I have y plus 3 quantity squared is equal to the square root of 2y plus 9 quantity squared. So we're doing that to get rid of the radical on the right-hand side, but we're going to need to distribute y plus 3 times y plus 3. Because there's addition, there's more than one term in here, we can't just square each piece. So we have y plus 3 times y plus 3 is equal to 2y plus 9. So let's distribute y plus 3 times y plus 3. That gives us y squared. I'm going to kind of skip the step and add our middle terms right now. So this is a 3y plus a 3y, so plus a 6y. And 3 times 3 gives us plus 9. Is equal to 2y plus 9. So now I look at this, I don't have any more radicals. So I look at what type of equation it is. It's quadratic. That means I want to set it equal to 0. So I want to get everything to one side of the equal sign. So let's subtract 2y and subtract 9 on both sides. So doing that, we get y squared. Well, 6y minus 2y, so we're going to get a plus 4y. And 9 minus 9, those cancel, equals 0. So solving this, we can factor out a y from both of our terms on the left. So that gives us y times the quantity y plus 4. That is equal to 0. So I have two solutions for answers. Y equals 0, y plus 4 equals 0, which is y equals negative 4. So we need to check. So wherever I see a y, I'm going to place parentheses there in the original equation. And so I have a y, so I'm going to place a parentheses. Is this equal, question mark, square root, I see 2, I see a y, so let's put a parentheses, plus 9, outside of the radical, and then a minus 3. So let's look at when y equals 0. So I'm going to go in here and I'm going to plug in 0 wherever I see that square root, and I'm going to simplify. So we get 0. Is this equal to so the square root of 2 times 0 is 0 plus 9. So the square root of 9 minus 3. So 0 is equal to 3 minus 3. Is that true? And yes, that's true. So 0 is the solution. And now let's look at y equals negative 4. So again, we want to go back to the original equation, and wherever we see a y, we're going to replace it with, in this case, a parentheses and then put 4 in there. So we have parentheses, is this equal to the square root of 2 times parentheses plus 9 minus 3. So replacing negative 4 inside the parentheses. Let's simplify and see if that works. So is negative 4 equal to, well, 2 times negative 4 underneath the radical, that's negative 8 plus 9. So that would give me the square root of 1 minus 3. So is negative 4, is that equal to 1 minus 3? And that's false. Negative 4 does not equal to negative 2. And so since that's not a true statement, -4 is not part of our solution, and y equals 0 is the only solution to that equation. Okay, so sometimes we are given equations, and if you look at it, you can manipulate it to look like a quadratic equation. So here is a tip about that. So far we've been asked to solve quadratic equations that are in the form of ax squared plus bx plus c equals 0. Often, rather than being asked to solve the quadratic equation, we might be asked to solve an equation that can be transformed into a quadratic equation with an appropriate substitution. So we'll do this to find some solutions of each function in the next example. And so let's pull in an example. Move this. So our next example, we have the following. We have x minus 3 in parentheses quantity squared plus 5 in parentheses x minus 3 in parentheses minus 6 equals 0. And it's asking us to solve the following equation. And so right now we could do it with methods that we've done in the past. We can expand that x minus 3 times x minus 3, distribute the 5, combine like terms, and then try to solve it that way. But if you notice, what's inside the parentheses is the same. And notice if we choose, and I'm going to use u, let's choose u to be what's inside that parentheses, x minus 3. And let's go back and let's rewrite this equation now with u instead of that x minus 3 parentheses inside the parentheses. So wherever we saw that parentheses, we're going to replace it with u. So and this would give us u squared plus 5 times a u minus 6 equals 0. So now we have a quadratic equation and it looks like it factors. I need two numbers that multiply to -6, but it would add to a positive 5. So 6 times -1 is -6, and 6 plus -1 is positive 5. So we can factor this as u plus 6 times u minus 1 equals 0. So solving this, u plus 6 equals 0 when u is -6. And u minus 1 equals 0 when u is 1. Well, our equation didn't have u in it originally, it had x. And so we want to go back and we want to solve for x. Well, we had chosen u to be this x minus 3. So when u is equal to -6. Let's figure out what x is. So let's go in here and plug in what u is. So we have -6 is equal to our x minus 3. So if I solve my x value, I can add 3 to both sides. So I got -6 plus 3, which is -3. So there's one solution. And let's look at it when u equals 1. What's our other solution for u? So we're going to plug in 1 in here for u. So we have 1 is equal to x minus 3. Solve for x there, add 3 to both sides, we get x equals 4. We didn't do anything when we were solving this equation by raising both sides to an even power. So as long as I did my mathematics right, then the solution these should be my solutions. So noticing this and rewriting in a quadratic form has made this so much easier to solve than expanding and then solving. And I just want to show you that really quickly. If I looked at x minus 3 times x minus 3 quantity squared, that would have given us x squared minus 6x plus 9. If I would have distributed the 5 inside the parentheses, that would have given us 5x minus 15 minus 6 equals 0. So let's combine like terms. I have an x squared. We have a negative 6x plus a 5x. That gives me minus x. Then I have 9 minus 15. Well, 9 minus 15 is negative 6. And then negative 6 minus 6 gives me minus 12 equals 0. So factor this. There's two numbers that multiply to negative 12 and add to negative 1. That's a negative 4 and a positive 3. So x minus 4, x plus 3 equals 0. Set each equal to 0. And so we get x is 4 and x is negative 3. So I kind of went fast going through the expanding the terms and distributing, but we get the exact same answers, either method that we choose. Okay, so let me do another example. So in this case, let's say we have x plus 3 square roots of x minus 4 equals 0. Okay, so here's an example that has a radical in it. So I could use the process that we were just going through and isolate that radical and solve that way. Or I can look at this and manipulate this to look like a quadratic equation. And so recall, if you had, let's say, the nth root of b, we could rewrite this without the radical as b raised to the 1 over n power. So I'm just going to start with that. I'm going to say this is the same thing as x plus 3. Instead of square root of x, I'm going to write it as x to the 1/2 power minus 4 equals 0. And so if we choose u to equal x to the 1/2 power, we'll recall that power to power with exponents is multiplication. And so I can rewrite x as, let me just do this first, x to the 1/2 squared plus 3x to the 1/2 minus 4 equals 0. So now I'm going to go in wherever I see x to the 1/2, and I could have just kept it as square root of x if I wanted to. I'm going to let u equal the square root of x, or x to the 1/2, and that would give me u squared plus 3u minus 4 equals 0. So now it's quadratic form. I notice again, this is a quadratic that I can factor. There's two numbers that multiply to negative 4 and add to positive 3. So this would be u plus 4 times u minus 1 equals 0. So setting each factor equal to 0, u plus 4 is 0 when u is negative 4. And u minus 1 is 0 when u is equal to 1. So let's go in there and let's solve for u in each case. So when u is equal to negative 4. So I'm going to go up here and I'm going to replace u with negative 4 and solve for x. So we get negative 4 is equal to the square root of x, or x to the 1/2, it doesn't matter. But in order to solve for x there, I actually have to square both sides of my equation. So squaring both sides of my equation, I'm left with 16 is equal to x, or x is equal to 16. So I need to be careful, because notice while I was solving in that that form, I squared both sides of my equation. And so I'm going to actually have to check. So if we go back in here into our original equation and we plug in 16 wherever we see an X, we want to check to make sure that that's a true statement. So wherever I see an X, I'm going to put a parentheses. So I have parentheses. My pen stops working. Parentheses plus 3 times parentheses, square root of parentheses, minus 4. Is this equal to 0? So plugging in 16 wherever I saw my parentheses and solving. So here we have 16 plus 3 times square root of 16 is 4. So 3 times 4 is 12. Minus 4 is this equal to 0. And I can see 16 plus 12 is minus 4. That's not true. That's 28 minus 4. That's 24 equals 0. And this is false. So 16 is not a solution. And I also need to find the solution when u is -1. So I'm going to do the same thing, not -1, +1, and plug it into what u was. So when u equals 1. So in this case, we would have 1 equals x to the 1/2. We can square both sides. We get x equals 1 squared, which is 1. Okay, so again, we need to check because we squared both sides of the equation. And so we want to know is 1 plus 3 times the square root of 1 minus 4, is that equal to 0? So I have 1 plus 3 times 1, so that's 3, minus 4, and I see that that is 0. 0 equals 0. And so that does work. And so my solution, it's not u, it's x equals 1. Okay, so we would have one answer to that. And so there's multiple ways that we could have approached this. We don't ran out of time, so I can't use the method that we were using to solve for radicals. But sometimes manipulating, and they're not always possible, but sometimes manipulating your equation that you're starting with to look like a quadratic by some sort of substitution can be helpful to solve. So that is the end of 1.4 in our textbook.